It's a very democratic setup, I will take your opinion. What do you think? There are only
I
few
think
slides left.
we can complete the last day's session first,
Okay,
then
okay,
we can move to AWS.
right, sure. So we have seen all the tools and why we are learning these tools. We have had a detailed discussion about that, and then we see how these tools are fitting into various phases of the SDLC. Okay, uh, I will make this screen a bit bigger. So the most used DevOps tools, and you know that it's an iterative cycle. It is not a single, it's not a linear progression. It is just an iterative because we need to, at every stage, we need to ensure that we are meeting with success. We should not fail in a very late latter stage. So we had chalked out a plan. We will deliver the code. We will build the code. We will test the code. And finally, we are using the pipeline to deploy the code over to some environment. And then there will be some operation work. And finally, it will go to monitor once we have delivered it to production or some other systems. Okay. So where are those tools that we have discussed fit in? So if you check on the plan and the coding, so if we group them together, then there is the Git, the Subversion, the Jira. These are the tools which will definitely fit into this particular thing, and out of which we are going to learn Git in our, I mean, in our, uh, you know, paid course. Then on the build stage where we are definitely going to build our code, then we need Gradle, Maven, or Apache Ant. Apache Ant is a bit older thing. It needs a bit of programming skills to be able to build your code. Whereas Maven, Gradle are much more popular. So there are a few more builds as well. Okay. But the Maven is very popular. So we will be learning about Maven at this stage. In the testing part, we generally do not deliver any, I mean, our sessions on JUnit, XUnit, or Selenium because those are out of our scope to learn because these are mostly for the testing team. And you know that as we have discussed that AI has impacted this particular area. So basically, we will not be learning much about those automation tools of testing. Then there is the integration tool, that is the CI/CD pipeline. CI means the continuous integration and continuous delivery and deployment. So we used to learn Jenkins quite well with our old batches, but then as the GitLab came into the market, we had a feedback that most of the recruiters are looking for a knowledge on GitLab. So we started training on GitLab, which is a CI/CD pipeline. But then again, as the industry keeps on changing, we started delivering on, or we have started uh, on Azure DevOps. So either Azure DevOps or GitLab or Jenkins, both, all the three are very good. In fact, they are the best tools available in the market. But we are now focused on delivering on Azure DevOps because Azure DevOps comes up with a lot of options and which are very useful. I mean, they have bundled in so many services within that it becomes much more easier to handle a pipeline for automation. So this pipeline will be built with all this. There is Bamboo and there are other tools as well, but we will not be focused. We will be focusing on Azure DevOps part of the CI/CD tool. And on this deploy part, when we are ready with our test, we are very good to, we have approved them to be deployed onto any, I mean, in the test environment or your pre-production environment for UAT or for the production finally. Now there we will deploy along with Docker, that is containerization part, or with a Vagrant. Karthik was telling something about the virtualization. Okay. VMware, or hypervisor. So we may be using a Vagrant, but we will be very fine doing Docker. Docker is very famous orchestration, I mean the containerization tool, and therefore we will be using Docker instead of a virtualization tool. We can also use Puppet, but we will be restricting our discussion with Docker only. Then we come to the combination of deploy and operate. Operations will be taking on your whatever the delivery that you have given, and they will have to make a lot of configuration changes, okay, orchestration changes. So we will have a provisioning tool like Terraform and a configuration management tool like Ansible. We will learn this. As well as in this operate phase, we are having Kubernetes. The Kubernetes is basically a particular orchestration tool. Once we have known Docker, we know containerization, and then we have to expand that idea of containerization into a network of or orchestration of the containers. So in that case, we will be very well, because that is in the market demand is there for a lot of your knowledge will be required on Kubernetes. And in fact, we are going to do a project, a capstone project using Kubernetes. Earlier, when we were learning GitLab, we were not doing Kubernetes, but once we are into Azure DevOps, we will learn how to deploy our pipeline, automation pipeline onto Kubernetes and get our pipeline automated with various jobs, with the integration of various tools. That will be quite an interesting capstone project. Okay, and then we have the monitoring. Once we have delivered our product into production, deployed it over production, then there comes the monitoring tools, because we have to be vigilant 24/7 on what, how your product works on the production environment. That is the challenge, and there is where many of the products fail. Okay, if you do not monitor it very well before the customer comes back to you with a service request or some issue, you should go back to the customer with a solution. It is like you are in the market before the customer is. You know the taste of the customer or the customer pain points. So a monitoring tool will be like, here is the place for your, there is a subject coming up very fast, which is SRE. SRE is your, this part is the SRE. System Reliability Engineering. So this is, and the ELK is a combination of few softwares. I will not go into the details because we are not in the DevOps. DevOps, the next stage for DevOps is either you can jump into DevSecOps, which is cybersecurity, part of cybersecurity, or you may have a stage of SRE. So if you are very good in giving a stability to the organization through the SRE tools, then you are actually, you have championed DevOps, the related SRE, as well as DevSecOps. That will be an ideal combination. But yeah, after DevOps, you can directly go over to learning DevSecOps or cybersecurity. Then there is a very famous tool called Splunk, but it's very costly, and Nagios. So these are all champions of monitoring. So mostly the operations guys should be upgrading their skills with any one of those tools, monitoring tools. Otherwise, it will be very difficult for them to sustain their jobs as an operation guy. Okay. Any questions? No question is a big question. Anyway, so let us move ahead. So you know that these are the processes. What is that? Continuous development. This is a continuous cycle of planning and coding, planning and coding, coding and planning. Continuous testing. So you build the code. Every time you change the code, you have to build it, and therefore you have to test it. So it's a continuous testing. Then there is the continuous integration. It is not only your continuous testing or development. You have to continuously integrate between the various phases through the pipeline, automation pipeline. Okay. So you say continuous deployment. So what you do, you continuously deploy and configure your environment or provision your environment and all those. So this will come, or you continuously orchestrate. So you will be using tools like Terraform, for the provisioning, Ansible for your configuration management, and Kubernetes for container orchestration. So here you will have the containerization with Docker for the deployment. Here you are basically, we will have one session on Docker. We will understand why we need a containerization. That is, we will convert the code, the software into images and put those images into containers. And those containers we will deploy over into an orchestration in a network of cluster of servers. And I mean, in a cluster of network, we will deploy hundreds and hundreds of containers, which are nothing but the applications. And therefore, the last stage will be to operate as well as to monitor, which is continuous monitoring. So C is a continuous activity. Continuous. Any question? So this is the last, I mean, this is a very important diagram, or what you can say, it is most important to know, understand. As a developer, this is the starting point. The developer will continuously deploy or deliver the code. Where? And the code changes. Where? On the version control. So it will be on a GitHub or a Bitbucket or a GitLab, whatever the repository, GitLab, or Azure DevOps repos or Bitbucket. These are the various version control tools. Okay. And once it is there, then there can be a trigger. It can trigger a pipeline. Once there is a change, it can trigger a pipeline. This is a pipeline, CI/CD pipeline. This code will move through the pipeline and get continuous integration through the pipeline. And then there will be, so there can be your Docker. So there will be build tools like Maven or code checkers like SonarQube, Maven, SonarQube. Okay, Maven, Gradle, and whatever you say. Then there is Docker. After you have built and everything, you will put that image or build an image into a container and deploy that container into some environment. Deploy the application over into an orchestration of Kubernetes, or maybe into a plain and simple testing server where there will be Selenium and other tools which will test your code. There will be SIT, system integration testing, and there will be a manual approval, though it is manual, I'm saying, but that approval also will happen over the pipeline. Okay, once the approval is green, that is go ahead. Go ahead. So what will you do? You will, so I'm saying if there is no bugs, if there is any bug, the feedback will go back to the developer. And this is a continuous cycle. It's a continuous cycle till you achieve 100% of foolproof. system. Because there will be a continuous monitoring and it will go to the developer. The developer will again change the code, correct the code. Again, it will come to the version control. There will be a trigger on that branch where you select that branch for a trigger point, and it will again build, again containerize, again deploy. Again, there will be a SIT and all those stuff. So finally, when you achieve 100%, it will go to a continuous deployment and delivery. Now it will be delivered to a pre-production server after the approval is green. Okay, pre-production server, and if there will be a UAT, user acceptance testing. So there you will use Terraform to build that pre-production server. Okay, and with the network security and all the stuff, you will do all with Terraform and Ansible. You will configure the softwares that are requisite for testing your particular product. So you will do it with Ansible, and then through the pipeline you will deploy it over the UAT, I mean pre-production. There will be a testing, a user acceptance testing, and finally, if this is passed, you will deploy it to finally to production. There will again be an approval system over the pipeline, and if the approval is green, the pipeline will take it over to the production. And there will be tools like monitoring tools which will start working on the system. And again, it can go back. If there is any issues, it will link up to this particular path, and it will go back to the developer. So this will be a continuous process. Is there any question? Will there be any question or no question? So as you know, there will be developer who is instrumental in doing this continuous development. Then there is the continuous integration, for the DevOps lifecycle, you need to integrate that. And there is your deployment, continuous testing, and finally continuous monitoring. So these are the various tools: Kubernetes, GitLab, Nagios, Puppet, Terraform, Git, Docker, Ansible, Azure DevOps, out of which we will learn Kubernetes. We used to learn GitLab, but that has been replaced with Azure DevOps. Okay, we will learn no Nagios, no Puppet, because we will learn Ansible instead of Puppet. Then we will learn Docker, we will learn Git, we will learn Terraform. Okay. So Git is definitely a tool that we will be using under continuous development. Then Azure DevOps is a tool that we are going to use as a pipeline for a continuous integration. Then we will use Docker and Ansible and Terraform for continuous deployment. And we will use Selenium, if at all, for continuous testing. And we will use either Nagios or Splunk or ELK for continuous monitoring. So this is the same picture now with the tools. So a developer will put the code into Git or GitHub. The Git is a technology, GitHub is the repository. And it will be either Azure DevOps or GitLab, which will be the pipeline integrator or the integration tool. And we will use Docker, Terraform, and as well as Ansible to be able to deploy and deliver to the testing server or pre-production server. And then there will be monitoring tools, which will, like the Nagios, which will monitor on the production server. Okay, and it will give a continuous feedback back to the developer, and the cycle will continue. Any question? So we have seen that, this diagram. So who is a DevOps engineer? A DevOps engineer is an IT professional who works with the software developers, system operators, other production IT staff to administer code releases. So basically, a DevOps guy will work with every part of the software lifecycle. So developers, operators, operations team, the production team, administrators for code releases. This is the main purpose. DevOps engineers should have hard as well as soft skills to communicate and collaborate with the development. So why soft skills? Can anybody highlight what are the soft skills needed? Hard, of course, the technology, the knowledge of the tools, that must be there 100%. But you also need soft skills. What are the soft skills? Because remember, you are a bridge between so many teams. You are working between them. So this is a smile. You are providing a smile to each and every team by bridging a gap between them. Okay, and so you need some managerial skills. Not only the technology, but your some soft skills are needed. Specifically the communication skills. You need to have an overall idea of the entire business and the flow, SDLC. Because the developers, the operations, the testing, they are operating in a very silos. They are operating in a discrete manner. They are only specialists in their own area. But you cannot work in silos, or you cannot work discretely. You have to integrate between all the teams. Okay. Therefore, you need to have some communication skills, very good communication skills, managerial skills. A DevOps engineer will work with the development team staff to tackle the coding and scripting needed to connect elements of code like libraries or software development. That this will come with your experience. This cannot be grown over a day. The more and more you interact with all sorts of, you do not run away from the problems. You should attack or face problems. Do not run away. Because the more and more problems you face, the more and more referent power you will get. This is why we work. It is not only the money. You need to be a go-to guy. That gives you the referent power. Somebody will always refer to you, saying that you must go to Mr. Karthik. Karthik will have the solution. If you can attain that referent power, that is what you achieve. That will give you, end of the day, you will be the most happiest person. Maybe money is not always the determining factor. There is a job satisfaction. You need to attain this level of expertise. The more and more problems you face, the more expert you become, more referent you become. Any question? So we are towards the end. We will do the Git in our, the job ready training. So I am now going back. I'm going back to our, what is that? The main, what is the agenda for today? That is our AWS. Any question of whatever we have learned so far on the introduction of DevOps before we start AWS? No questions, right? Okay. Okay. Can you see the screen clearly? Hello. Is the screen visible and am I
Ye-
audible still?
Yes, we can see the screen and you're still
Yes,
audible, sir.
we can see your screen.
Okay, great, great, great. So I will not make the screen totally fully occupied. Let this bar come, the very status bar. Let it be there. So let us move on. So what is a cloud computing? Cloud, by this time you must be everybody would be knowing about the cloud. I do not need to emphasize more stress on it. The importance of cloud. What is cloud computing and who should be using cloud computing? Who are using cloud computing? So basically, I will just point out one thing. The key point is the most important is on-demand delivery. It is something over the internet. There is a place where you ask for something, you get that something. It is on-demand delivery. So the Netflix, you are very much aware of these services from Netflix. You demand a video to be downloaded or to be you want to view a movie, so you demand for that, and that will be easily available to you over. That is a service that will be provided just without any, I mean, without any questions raised, because you are a customer of Netflix. You you can demand a service like that. So that is possible because of the cloud computing. Somewhere in some place, a server is there for Netflix, which is, and you are staying somewhere at a very remote corner of the world. Okay, you just being a customer, you have the right to demand a service. So on-demand delivery of IT resources, information over the internet with pay-as-you-go pricing. This is a very important concept. You do not pay for what you have not used. Okay, pay as you go pricing. Instead of making a capital investment, you invest for the service that you need at that point of time. That was possible because you have the cloud services. So you do not need to buy it beforehand. You buy it real time, or you use it real time and pay it later with the bill. Okay, you do not need to pay it. You do not. There is no postpaid concept. It is a real time concept. So instead of buying, owning, and maintaining a physical data centers, and therefore you have a lot of capex. A company is having a burden of capex and opex, capital expenditure and operational expenditure. A lot of them. A company is always looking out for cutting the cost. And what best place is to take out all the legacy services or the technology and put it over the cloud. Migrate. So you have migrated all your services over the cloud. Therefore, you have no liability of maintaining your data centers. It is very, very costly. There is no point in maintaining your costly data centers. And what is that? You are using only 30% to 40% of the investment. You cannot optimize fully 100% of your capital investment. Always there is a lack. So why to lose that 70%? You do not need to pay upfront for something which you are not going to be using. So it is better to do it as you go. So pay as you use. Okay, for the computing power, storage, databases as on the need basis for a cloud provider like AWS. Who is using cloud computing? Operations of every type, size, and industry are using the cloud for a wide variety of use cases, mostly for your medical insurances, any sorts of insurances, or hospitality services, any you can say for any storage services, data backup, disaster recovery, email, virtual desktop, software development and testing, big data analytics, and customer facing web applications. So mostly the healthcare companies are using the cloud to develop more personalized treatments for the patients. So the customer or the patient is in India and getting the services of a doctor sitting in US. Okay, so those are the giants or the power of the cloud to deliver the services. And real-time fraud detection, the banking sector, they are all the heavy users of cloud. What are the benefits of cloud computing? I don't need to highlight this point because this is always uh, the agility, the speed. This is the symbol of speed. And these diagrams are from this, whatever the things that you are seeing is from Amazon site. Okay. So you are agile. You are just in time, JIT to the market. Amazing thing is about an example of agility. The server that you used to build, say almost 15 years back, it used to be a 1 week or maybe 2 weeks, 1 to 2 weeks to build up a good server. You have to go for the OEM, original equipment manufacturer, and the service engineers from them. They will install the big server at your data center or at your office premises. What will happen? They will install all the networking elements, that are needed, and the operating system, OS, databases. So it will take around 1 to 2 weeks to stabilize a big server like this. With the help of cloud, with the speed, I'm taking an example of the speed, you are doing it less than a minute. Can you compare 2 weeks versus 1 minute? No comparison. No comparison at all. That is the speed that we are talking about. So once you have saved almost 2 weeks time, you have saved a lot of money, saved cost, operations. So many. You have saved a lot of time, and saving a lot of time is saving a lot of money. So this is one example that I have given. There are lots of examples like that. Data storage, the data storage and retrieval. 15 years back, this used to take, like the police department. They want to track a particular data for a criminal, okay? And that crime has happened almost 1 year back. 1 year back. They have got some certain clues. But the data is by 1 year, the data has grown so large in terms of terabytes or in terms of petabytes that it will take almost 1 week, 1 week to retrieve that 1 year old data. Okay. Are the police going to get any benefit out of that? So within 1 week, the criminal has already crossed borders and have taken asylum into some other country where this particular police doesn't have any effect. So just in time, if the information is not available to the police department, there is no use of that information. That used to be 15 years or 20 years back. Now, today you cannot think of waiting for 1 week for a particular information. Even if you have to search within a haystack, a needle, it is possible within minutes you will get that information. So that is the capacity of storage and retrieval, the technology provided over cloud. Another is elasticity. You do not over provision your resources upfront. You do not need to. You ask for that resource and the resource is available to you. So why do you need to install that resource or provision that resource beforehand? It will be available on the fly. So you do not need to over provision. So as per the business activity, as your business grows, your usage grows. So your resources needed to cater to that usage will also grow dynamically, elastically. And whenever the demand of those resources reduces, when it reduces, automatically it will shrink. Okay, it will shrink. So it will grow and shrink at the same time. So it is like an elasticity. So it will grow and it can compress at will. So during the Christmas, your server is quite busy. Lots of requests coming for some services. Okay, during the Christmas, as a high business activity time. So it is the peak period. So that server now, which used to process 10,000 requests per second, had the capacity per second, now is 1 million. 1 million requests per second. So do you think with the same resources, it will be able to cater to 1 million requests per second? No. So what will it do? It will ask over the cloud for additional resources to be added to auto scaling. It will grow horizontally or vertically. So auto scaling will happen with the help of cloud services. So it will be added. There are more and more resources will be added so that you can cater to the to 1 million requests per second. That capacity you can gain. And when after the peak period is over, that is off peak, you will reduce it to 10,000. So the resources that used to be added will now be taken out. You are not using them. So if you are not using them, you will not pay for them. So it is like you are expanding, you are contracting. This is the lean usage. This is the maximum usage. So it is like an elasticity. It can be provided by cloud. Any question? Cost savings. As I told you, you save your time and you save your cost. There is no doubt about it. That is the general philosophy. The cloud allows you to trade fixed expenses such as data centers and physical. So there is a trading. There is a trade between the fixed expenses and the variable expenses. So you only pay for IT as you consume it. Nothing extra you pay if you have not used the resource. No extra concept or no pre or over provisioning. Not needed. This concept is too backdated. Okay, so the variable expenses are much lower than what you would pay to do yourself because of the economy of scale. Economies of scale is a very important term. EOS. This economy of scale is very much in practice when you are using cloud resources over the cloud. You can deploy globally in minutes, as I told you, which used to take 2 weeks, now can be deployed over 2 minutes. So you deploy, and you can deploy it anywhere. You can be in this part of the world and you want to deploy it over this part of the world. It can be done over 2 minutes. There is no latency. It does not need, you have to cross physical locations. Yes, there is security things, security groups like firewalls, and so many things will be there in place, but everything is synchronized and everything will be for you to serve the best. So it will be deployed globally if you are following the rules. Any question? Today, nobody is asking any question. So this is a very nice picture. I like this one. This is from Amazon. They have partitioned the entire services into various layers of service. Various layers. These are the foundation services. These are the application platform services, and these are the management and administration services. As a DevOps engineer, you must know these foundation services and management and administration services. This part is for the developers and architects. Okay, there will be certificates for solution certificates, solution architects, certificate over the cloud. But as a general cloud practitioner, you can get cloud certificates if you are very good in your foundation services as well as management and administrative services. Okay, the entire globe is divided into regions. The entire globe is divided into regions. So there will be your regions in every quadrant to better govern the administer your services all over the world. So AWS global infrastructure is enabled with the regions, and the regions are divided into availability zones. These are nothing but the data centers. So if I'm talking about India, we have a data center in Mumbai. So Mumbai is the region, and Mumbai will have availability zones. So Mumbai region is AP South 1. This is the region code. This is the region code. AP means Asia Pacific, South 1. That is for Mumbai. There are many regions, out of which AP South 1 is Mumbai. And Mumbai will have availability zones. Availability zone 1, availability zone 2, availability zone 3. So what are these availability zones? These are nothing but your data centers. Data center 1, data center 2, data center 2, 3. And they are, you see, the region is VPC, Virtual Private Cloud. A default VPC is enabled for each and every region. So they have built your infrastructure automatically. You just have to use, you are a consumer. You will be using the Mumbai VPC, Virtual Private Cloud. You enter the VPC through the edge location. Okay. So through the edge location, you enter the VPC, and that VPC will take you to the availability zones, that data centers. And the data centers, the network element is called what? Anybody has any idea? Like this is a network element, networking element. This is also a networking element. Uh, can anybody tell me what is the name actually for that? A VPC will be divided into 3 something. What is that something?
Subnet.
Subnets. Very good. This is subnet 1, subnet 2. So these are default, subnet 2 and subnet 3. This subnet will be, let's say, AP South 1A, then 1B, 1C. So subnet 1A, 1B, 1C. These are nothing but the data centers over a network element called subnet. So VPC is divided into 3 subnets. So maybe Ohio is US, maybe east or west. I'm not very sure. I have to check. US East 2, that is Ohio. That is the region code, and this will be having, because this is a big area or region, it will have 6 availability zones. 1, 2, 3, 4, 5, 6. So what will be the subnets? Can anybody tell me? If this was AP South 1A, what will be Ohio subnets? Subnets means data centers. There's a big region, so there are 6 availability zones or data centers. But what are the subnets? What will be the name of each of the subnets?
US East 2A, 2B, 2C, like that.
Correct. Exactly. Fantastic. That is how they have designated your global infrastructure, such that they can govern and deliver the services without any latency. The term is, that means that you are working in India, but you are in Mumbai, or you may be in Kolkata. Okay, but you are working on a server which is in a data center of US East 2, that is Ohio. You are some 1,000 miles away, thousands and thousands miles away, but you will not see as if you are doing a work in Kolkata or in Mumbai, just next door. You will not feel the latency. That is how good the networking architecture is, how well the services are delivered. Okay, so as if you are doing you are processing locally. And in this foundation services, you have compute service. These are all services. Okay, storage service, database service, networking services. So under the compute, you have the EC2 instances or Amazon EC2. EC2 is Elastic Cloud Computing. There are 2 C's, and most of the services in cloud or AWS is with Elastic. They are very fond of this term, Elastic. Why? Because it can grow and it can compress, it can shrink without your knowledge. This is a background process going on. It is auto scaling. So your server can grow up horizontally or vertically. So that's why it is called Elastic Cloud Computing. You will be computing over the cloud. That means these are servers. very small servers, nano servers you can configure, or you can go for a very, very big 2x large servers. Okay. So auto scaling, these are the computing services regarding your servers and related auto scaling services. Under the storage, you have a very famous S3 service, S3 bucket. Many companies, even if they have not gone for many of the services, they definitely go for the Amazon S3 bucket services, storage service. This is one of the most popular services of AWS. Then there is the elastic block storage. Elastic block storage is like a hard disk drive, or SSD, solid state device, which is optical disks. So they can be of. So you see, these are all available over the cloud. You are just paying as you use, and those payment is not are very, very, very minimal, very minimal. You can't believe how big the EBS can go, but you are using it. The moment you stop using it, there will be no charges. There is a storage gateway. This is a gateway services of big storage. You won't be, there are trucks, trucks, huge Amazon trucks, AWS trucks, which physically come and take your data, and those data is unthinkable. Petabytes of data in just small disks, petabytes of data, and those can be. So this truck will come to you, they will load your data into the truck, physical trucks, and they will be delivered to this. So this can be physical, or there is glaciers which are logical storage. You can see glacier means a huge amount of something. That is a glacier. So you can export your data from your office, one is in US and one is in India. So you have generated a lot of data over here. You want to get those data shipped to India office. You do it through AWS Glacier services or the storage gateway services. This we are going to learn. Then in the database, you have the RDS. RDS is relational database services. That is, you have learned about RDBMS, a relational database management system. They're like Oracle, Sybase, Informix. There are huge MySQL, SQL Server. Okay. So those are databases, but those databases like these are, you have a client server architecture. So you have a database server, you install your Oracle over here, and then you have a client. That is an old architecture or old system where you have a client server architecture, but here you can have serverless, stateless, memory-based, or cache-based memory, or no SQL like MongoDB, no SQL databases. Simple databases, SimpleDB, DynamoDB. DynamoDB is the NoSQL database, like the MongoDB. And all these are managed services, one service is called infrastructure as a service. We are coming to those slides. Infrastructure as a service, platform as a service, and software as a service. So these would be whatever are databases that you are going to use, that is software as a service. So these are managed services, available. So this elastic cache is a memory database. But who is providing that? Amazon is giving that service to you. You may need only 20% of knowledge of database. The rest, 80% will be managed by whom? Let's say RDS or SimpleDB or DynamoDB or whatever. So this MariaDB, MySQL, which is MariaDB over or RDS, SQL Server, everything is available, but managed by AWS. Then on the networking part, you have the, as I told you, Amazon VPC, Virtual Private Cloud. That is a network element. Load balancing, Elastic, ELB. And there is network load balancer. These are two things. So these are services provided by AWS. You have to go for those services. Amazon Route 53. You know, you have, let me remove this. You know GoDaddy? What is GoDaddy? They are also a service provider over the cloud, the DNS service provider. Similarly, from the Amazon, you have Amazon Route 53, similar to services provided by GoDaddy. Then there is the service AWS Direct Connect. These are the various services provided from the networking section of the foundation services. I will not go into details of the cloud front, the messaging, the search, like the Google search, which is the cloud search over Amazon, the map reduce. This is serverless computing. These are Amazon SWF, map reduce, elastic map reduce. This is for your, or you have the lambdas, lambda processing. So, but these are, as I told you, these are for the developers and the architects. These services are meant for developers mostly, and they will you will have the automatic libraries and SDKs of Java, PHP, Python, Ruby, .NET, whatever you see, everything will be there. For the management and administration, you have the Amazon AWS console. If I get some time, I will show you how we can use a console. This is a service, AWS service, to create your compute service called EC2. This one, I will create a server through the console, through the management console, and within 2 minutes, within less than 2 minutes, less than 1 minute, I can produce a server, and I can use my laptop to be able to connect to that server that I have created over the cloud. Just if I get some time. If not, I will carry that particular hands-on the next weekend. So there is your identity and access management. This is a very important functionality called IAM. This IAM is one of the instruments our study in the DevSecOps. You will be giving role-based RBAC, role-based access control on this particular users called IAM, identity and access management users. So you can federate your identity, and also go for a consolidated billing. These are the services. A deployment and automation. You can automatically deploy using Elastic Beanstalk, CloudFormation. These are the various important topics that we learn in our DevOps job ready training. Of course, we do not do this CloudWatch. CloudWatch is mostly for the operations guys for monitoring. Like you have Nagios, like you have Splunk. Similarly, Amazon is also providing a very nice service called CloudWatch for monitoring. Any question? You have any question? There are lots of words. I think a picture, I will explain this through a picture, through a diagram. A picture says, picture can say 1,000 words or sentences. Okay, so let us understand this entire models of cloud computing models through some picture. Okay, again, this is those models, cloud computing models called IaaS, infrastructure as a code or service, infrastructure as a platform as a service, or software as a service. But to understand then, let us not go through the line by line. Let us understand that using this picture. You see, you have on-premises. That is the most primitive sort of without a cloud. So this is with this minus cloud, no cloud architecture, no cloud technology. So in a company, they are having all this blue part are all the part of the infrastructure which you manage. You means the company manages the networking, storage, servers, virtualization, operating system, middleware, runtime, data, applications. All are managed by the company. So can you understand the nature of capital investment and operational investment? For each of these layers, you need to employ a very skillful guy or an expert to manage your networking. You need to have a networking team. For the storage, which is also a very vital part, you need to have a storage team. For the servers, you must have administrators who can administer your servers. Then for the virtualization, for the operating system, admins, middleware, runtime, everything. For the data is very important. For data, you have database administrators, and they are very costly guys. Then you have the applications and application developers and managers and all those stuff. Now you thought this is giving you a lot of cost. And also, even after you have spent millions and millions of dollars, you are not getting the user experience is bad. Something or the other is still going to happen every day, every now and then. So what you thought, you will provide the first four layers, networking, the lowest layers, networking, storage, servers, and virtualization to some other providers. You have given it to your cloud. So they are experts. So what you thought, I will give my, I will delegate or I will outsource these particular services to be managed by AWS, a cloud provider. Rest, OS, middleware, runtime, data, applications, I will manage. The company will manage. Okay. This is called IaaS. You are giving off. So this is infrastructure as a service. So this is the cloud service that you are hiring, the expertise of the cloud. That is why it is called infrastructure as a service. You are you are adding the cloud part. Somebody who is the cloud provider. In this case, it is, let's say, AWS, your cloud provider. Okay. You are keeping all these layers with you. You will manage. So after this, you found, oh, I'm saving a lot of money over here, and also I'm getting no complaints. It is as smooth as you can think of. So why don't we do one more thing? Let us give away this OS, middleware, and runtime up to this. 1, 2, 3. I will give it to again to the same AWS provider cloud. So this is another portion that I have given it outsourced to the AWS, to a cloud provider. And so therefore, what is that called? I have given up the entire platform. This is the entire platform I have given over to be serviced by the cloud engineers, or maybe the cloud provider, which is AWS in this case. You see? So it is called PaaS platform. You have given the entire platform to be serviced because they are experts. And once you have given this, you thought, oh, I have saved further lots of money, and also my headache is gone, and I am not getting any complaints. No service level issues. Everything is running smoothly. Whatever issues, they are handling it like an expert. So I'm very happy with them. Finally, I was not willing to part away with my data and applications because data is sacrosanct. Uh, Data is very, very private. Data has to be very secured. So you thought you are an expert. You can save your data or secure your data much more than anybody else. But that thing also has been broken. Now you thought, let us give away our data and applications to be managed by these expert guys called AWS. So this is sort of a thing is called SaaS. So basically, you have given the entire system has been integrated with AWS. The full software solution is with the AWS. So now AWS is managing the entire show on behalf of the company. That is called software as a service. This picture gives me a very good idea of what is infrastructure as a service, platform as a service, or software as a service. Any question? So if you are hiring a mailing service like Outlook or Google, Gmail for your company, okay, that means you have used a SaaS. So the entire mailing system will be operated or maintained by some cloud provider. That is a software as a service. So it involves the networking, storage, servers, whatever it needs to maintain the entire email service of a company. That is one part of a software as a service. Any question you might have?
Hello, Debasis. I'm not sure if I missed this, but could you please
Okay.
give an example of a middleware?
Middleware. Yes, the middleware concept is uh, something like the Tuxedo. Tuxedo was a very famous middleware. Uh, IBM used to use a lot of applications over Tuxedo. So you have your server, you have your client, server and a client, and there is something maybe on a separate server or maybe on any one of the either it is on the client or on the server. Mostly this part would be on the server. This is called the middleware. So it is sort of a business layer. business logic will be implemented, business layer. Business layer. Why I'm not? Let me use this. This is the database layer, and this is the application layer. Okay. So you have the data. You have the data to be flowed, to be available to the client. But before it goes to the client, the data has to be transformed into some business logic. Some business layer will act on it, and that is called a middleware. It is difficult to make you understand about these were legacy softwares when there were server client architecture. At that point of time, middleware were very famous, but like the Tuxedo. And there are many other very good middlewares. So they used to convert this data into and apply the business logic over it, and then provide that as a data represented to the client over the application. Okay. So this is nowadays this middleware is replaced with so many like you have the REST technology. REST. You will hear a term called REST APIs. Okay. This is because of over the cloud or over the internet, when you convert something into a business layer through the REST API and present the data to the client is replacing the middleware nowadays, because the technology has changed a lot. But to make you understand about what is infrastructure as a service, platform as a service, we had given this layer. Maybe this layer is not needed at all, right? For any company right now. Did I answer the question?
Yeah, yes, thank you.
Laptop.
Hello? Hello?
Yes, yes. Like the REST API.
I'm not getting you.
It's clear now, like when you use the REST API as an example to start.
Mommy.
It will be difficult for me to make you, if you are not aware of REST API, it is out of context right now at this stage to make you understand about how it functions. Okay. But what I'm saying is, what can I give you as an example? You have some data, but then, okay. Let me take an example of telecom. You have made a call. Okay, over the telephone lines or maybe mobile calls. That call will be registered where? In the switches, right? You have made a call from your phone. You have made a call, and that call will be registered over the switches, and that call is called a call detail record, CDR. It's a one record. It is, you can say, a data, but it's a raw data. Now, there should be some another gateway or a server that is called a mediation server. Mediation server with some mediation logic. I will not say business logic, a mediation logic. That means it will filter out the important part from the CDR. Not all information is needed. So it will mediate the CDR into some mediated data. I will say MD, mediated data. So between the CDR, between the switch and the mediation, the data is converted with some filtration, some business logic into some mediated data. Then this is not enough. then there will be another gateway or some server which or some application which will convert this and apply a business logic on it. Okay, so in case of billing, it can be RBMS, rule-based management system. This is, you can say, a middleware. Okay, which is applying the business layer. This business layer is applied, the business logic, because finally, if you had made a call, you have to pay for it. Are you getting me? If you had made a call, this call has to be rated. But you cannot rate this thing because there are lots of information which is of no use. So you have to mediate the data. Even after mediation of data, you cannot rate them. You have to give some business logic that if you have made a call in the deep in the night, you will be charged the lowest, the minimum. If you had made a call at the peak hours of the business, then your rates will be higher. So there will be some tariff, some business logic. Are you getting me?
Yes,
Am I being...
yes, makes sense.
Yes.
Thank you.
Yes. So that is called the middleware. That is the business logic. You are applying some logic into that, and there is another server. Now this is called the billing server. Now before the billing server, there is another server called the guiding server. There is so many things, and the entire life cycle. The guiding server will separate out the business logic and will apply those business logic into your tariff plans. There are tariff tables, and it will fit in to the best available tariff, the optimistic, or rather the fittest tariff that should be applicable to this particular call. Guiding server, and that guiding server, after it has applied some sort of a tariff, it will be going into the rating server or the billing server. So now your call will be rated. So there will be some charges. And finally, a bill will be produced for you for that call. And that call and lots of calls for that month will be collected for your account. And finally, it will be produced to you for payment. So you will get this bill and get a payment. So you see, you have started from a very raw CDR. You cannot rate them, but how you are gradually breaking it down and applying the business logic through the middleware, and finally being able to produce a bill for the charge. Is it now clear? More or less? How after the month, the total, all the calls that you have made and they have been rated, and now a billing will be provided, a bill will be provided to you. So is this sort of made some clarification of what I was trying to make out of middleware?
Yes, Mr. Debasis. Thank you.
Thank you. Okay. So after we have understood this, I think I have some more time, if Mr. Menon permits me. Okay. I will go to this. So you see, I have already discussed about cloud computing. So cloud computing means the EC2 instance. It is nothing but a server. It is nothing but a server, which is a virtual server on the cloud. Virtual server on the cloud. Okay. EC2 is a basic fundamental block around which the AWS is structured, because this is the server. And basically, when you talk about the infrastructure, you talk about a server. This is the basic building block of the services, because all the services are around this. How well you can use your server. to cater to the end users. End users are using a browser. Okay, they are sending the URL, the request, and the server is processing the request. So there is a request and there is a response back to the after the processing. So the processing happens over here and the response goes back to the end user. Okay, so this all the services are most of the services are oriented around this EC2. Clear? So we will see how fast we can create our server, whether it's a development server, whether it's a pre-production server, testing server, any server. You can create multiple servers in one operation. Multiple servers in one operation. You can create one server, single server, or 100 servers in one go. If the single server creation takes less than 1 minute, maybe creation of 100 servers will take around less than 2 minutes. That is the power of cloud computing. Okay. Then there is Amazon Machine Images. Can anybody tell me what do we mean by AMIs? AMIs, like you have bought a laptop, okay? You have bought a laptop and you started on the power. You have powered it from your power source and you find nothing. Why? Because you have only bought the hardware, a dumb machine. This machine cannot work on its own if it does not have an operating system. So you are creating a server, EC2 instance, an EC2 instance, a server, but you cannot build a server without having AMI. Amazon Machine Image. Image is the buzzword. And when we learn Docker, we will see how we can containerize or an application into an image. So basically, operating system is an application. It's a software application which drives or manages the resources of a hardware of the server. All the resources, whether it is the hard disk, whether the CPU, whether the memory, anything. Everything, all the peripherals will be governed and managed by the operating system. So you say, I will attach an AMI, Amazon Machine Image, is a special type of pre-configured operating system. And you know, earlier days, to install an operating system like Linux or HPUX on a server will take almost, if not less, it will be almost 3 to 4 days. And now within minutes, not even minutes, less than a minute, you are attaching an entire operating system like Linux, like Ubuntu, like Kali Linux, or like Red Hat Linux. The entire system will come into and get installed into this. Basically, you are not installing, you are attaching an image. It is like a plug and play. Plug and play. You plug it into your server, the EC2 instance, and that's all. Your operating system is there. Then that is the power of containerization, the image. That is the power of image. We are not, AWS supports virtual image or VMware as well. Like Karthik was showing you on his laptop, on Windows, the main operating system, the host operating system is Windows. On Windows, he has partitioned the Windows operating system into several virtual machines. And each virtual machine can be one operating system. So you are virtualizing OS. There is a VMware through the hypervisor. So AWS will also support VMware. Okay, any hypervisor, see, any hypervisor images. But generally, on a cloud, we always go for AMIs, which are full-fledged operating systems, images. I think we are good enough. Then there is elastic block storage. As I told you, these are the hard disks like a hard drive. It is elastic block store because it can keep on expanding or uh, contracting like an elastic. The storage can go up, can come down as per your need or as per your usage. The storage volume size ranges from 1 GB to 1 terabyte. So you can automatically attach 1 terabyte of hard disk into your server. It is like a plug and play. Okay. Elastic. Sorry. EBS snapshots. Now, EBS snapshots are like the EBS provides the ability to back up point in time snapshots because your data to S3. So today you have started up your server. Tomorrow, when you have started up your server, and then you started, and then you shut down when you are not using it, and tomorrow you again start up, but the system is not starting up. Something has gone wrong. So you could have started it up if you had taken a snapshot of the healthy system. So when you have started up this time, it was successful, you take a snapshot or EBS snapshot of the system. You journal the system at that point of time and save it in your S3 bucket. So whenever there is a problem in the startup, you will just pick up the previous snapshot of the server, and that will help to start up the machine. It is like a sort of a backup of point in time. You could do it over Windows as well. But generally, this is done very, very smoothly, effortlessly in EBS because that is a service provided by AWS. EBS snapshot. So these are incremental backups. You do not need to take a full backup. You just take a snapshot of whatever has changed today. So that will be applied. So only the blocks on the device that have changed since your last snapshot will be saved. Okay, it's an incremental backup which can help you to revive or restore your faulty system. So it is saving the good image. So if there is a bad thing, something is there, the good image will override and help the system to restore. Simple storage, S3. Okay, S3 is, as I told you, the most popular services. It is not a full-fledged, like it is not a hard disk sort of thing, which S3 can be shared over and it can be versioned. So many things are there. It is very difficult to let you know the application unless and until you have a hands-on experience on it. But for the time being, I can say that S3 is a data hosting service It is like a storage repository. Storing data and downloading data in S3s are built separately. So the use you will use it. Many developers keep their source code. Mostly they will be using GitHub or Bitbucket, but they can also use the S3 services, S3 bucket, to load their files, their images, and all those stuff. Because it is very easy to retrieve the data. It is very difficult to retrieve the data from a GitHub. Not difficult. You have to have a pipeline. There should be some architecture. But here you can directly access that from outside, view the data, load the data, store something into that, and you go happily without any doubt that your data will not be available tomorrow when you come back to office. You have lost all your data. No issues, because you have saved in a very secure place. Okay. Elastic load balancer. You know what is the purpose of a load balancer? So just quickly, so here is your server, and there are lots of requests coming in for some application which is hosted over this server. Okay. Now you decided that it is quite impossible to manage all the requests over onto one server only. So you distribute your application over several servers. Okay, the same application is distributed, say application A, application A, application A. So now you have replaced, not replaced, you have complemented one server with two more servers, such that your load will not be automatically distributed. So what you do, you implement another server or another piece of software, or maybe hosted on a hardware. So this can be also a server where you have installed load balancer. You have implemented load balancer. So now what you will do, you will direct all this request coming from, they will not go to hit the servers directly. They will come to the load balancer. They will all come to the load balancer first. The load balancer has a, a round robin logic. Round robin logic. That logic, that algorithm will help to distribute the load between the servers. So it is not now only on one server the load will be concentrated. It will be distributed. Let's say this one will be distributed over here, over here, over here. Depends on the logic. It knows how healthy or how busy that server is. It can find out and can redirect the request to another server hosting the same application. So this service is available if you are taking it from AWS. They are experts, but this service is a bit costly. Like the EBS snapshots, if you go for this service, it is costly. Like the Elastic IP, it is also a bit of costly service. Auto scaling, if you go for auto scaling, automatically it will scale up and down. It is also costly. Similarly, Elastic Load Balancer is a costly service. But S3 bucket services are very cheap. EC2 services are very cheap. Okay, that way it continues. Any question up to this point? It's clear. Very good. Thank you. Okay. So Elastic Load Balancer, there is a sort of fulfills a vital role that you could implement yourself using some dedicated EC2 instances. Don't reinvent the wheel. Use the ELB to do load balancing. So instead of going for implementing an elastic load balancer, when we learn about Kubernetes, we will do our elastic load balancer ourselves. We will not take the help of this SaaS services of AWS because it is a bit costly. But if you don't want to reinvent the wheel, the ELB is to do load balancing for you. ELBs are very important part of achieving a scalable cloud service, but an ELB does not scale your available resources. ELB is not for scaling. For auto scaling, you will have auto scaling services, which comes under compute services. So ELB allows you to efficiently use your available resources. That is the important point. There is a use case. DynamoDB, as I told you, it is a NoSQL database like a MongoDB. Automatically replicates your data synchronously across multiple availability zones within an AWS region. So you will have a high availability, data availability and data durability. Your data will not be lost because it will be automatically replicated. These are the services. These services make your cloud services so important. And you can easily, these are very low cost services. You can easily get it available for paying a minimal amount of money. Whereas to implement that in your own office, it will cost you a lot because the person who will implement that person's salary, it is exorbitant, too high. Whereas you are just using the services of AWS for a minimal cost, but you are getting so much automation designed for extremely high throughput, low latencies for both reads and writes. So dirty reads and dirty writes are so fast and with so low latency that it is unthinkable when you do it yourself. You administer your database yourself. So ability to scale to extremely large data sets. So you cannot think like the big data. Big data, you are thinking of data which is in terabytes. Within seconds, it can grow terabytes. So to handle that sort of, to query when the database becomes large, what becomes slow? When it becomes large database, what becomes slow? When your database grows extremely high, extremely large, your query becomes slow. When you try to read a data from a huge database, the query becomes very slow. The performance gets hit. That's why these services are so important, that your performance is quite predictable. If you want to have a 90% performance achieved, you can do it because you can predict it. You are using the DynamoDB or whatever the services. And the relational data services, RDS. These are like the relational database management system. These are SQL databases. Okay, where you can make SQL queries like relational entity, relationships. So there are hundreds of tables, and those tables are having some entity, one-to-one, one-to-one, one-to-many, many-to-many sort of relationships. Those can be implemented quite efficiently and with the SQL database, that is with the RDS. Okay, you do not need to be a database expert or database admin. You can have minimal. You will have 20% of knowledge of database, and the rest 80% will be done by the RDS service. That's why people are industry is moving towards all these services from the cloud. Today, we will stop over here. So we will discuss that because I'm lagging behind. It is like uh, an express train in India. When it is delaying, when it is running late, it will always run late till it ends up the destination. So it is like the same example. I'm running a bit late. So this train is going to reach the destination very late. So, but don't worry, I will not. I will reach the destination. We will reach the destination. Okay. So I will end the discussion today over here. I don't think anyone is there. I don't know.
No, we are here.
Oh, okay. Okay, great. Thank you. So, Mr. Menon, I will end the session today. We will see. We will continue the next week like we have done today.
Thank you, Mr. Debasis. Thanks a lot. Guys, I think we are end of today's session. So if you have any question, feel free to ask, or else we'll meet next weekend.
Thank you.
Because apart from the training to reach the job, you'll there are n number of questions and queries will pop up on your thought, and I think this is the best place where you can have those answer, and we'll try to guide you based on our best knowledge. So feel free to ask, or else thank you everyone.
Thank you, everyone. Thanks for your patience. It is not easy to do a 4-hour session.
Thank you very
Really,
much.
thank you. Thank you.